December 7, 1943. Bougainville Island, Solomon Sea. Staff Sergeant Mike Kowalski was pressed into the muck. The guttural cadence of Japanese voices, amplified by the swirling haze, grew closer. His Thompson submachine gun was spent. His M1 Garand rifle lay in pieces, its receiver fractured by shrapnel from a mortar barrage 2 decades earlier. All he had left were 7 rounds for his M1911A1. 60 yards away, the first enemy fighter broke from the tree line, moving with the practiced stealth of a seasoned warrior. Mike drew a slow, steady breath, a technique his father had taught him for hunting whitetail in the wild expanses of Michigan's Upper Peninsula. He raised the .45 caliber pistol, its familiar heft settling into his calloused hands. At 15 yards, he squeezed the trigger. The 230-grain projectile, propelled by American ingenuity, struck the soldier's center mass. The massive slug, delivering 400 foot-pounds of kinetic energy, halted him instantly. Meanwhile, 1,500 miles to the northwest, in a training facility near Raba, Lieutenant Tishi Yamamoto demonstrated the intricacies of their Type 14 Nambu pistol to a cohort of fresh recruits. "Ensure the magazine remains dry," he cautioned, glossing over the firearm's meager 200 foot-pounds of muzzle energy, a mere fraction of the American sidearm's power. 38 years prior, in Ogden, Utah, John Moses Browning's audacious concept was met with widespread skepticism. A tilting barrel mechanism unlocked by the firearm's own recoil. It seemed far too intricate, too prone to failure in the crucible of combat. Browning, however, merely offered a knowing smile and continued his meticulous work. The measure of a design, he believed, wasn't its perceived complexity, but its proven functionality. Back on Bougainville, Mike's 4th shot faltered. A gritty obstruction in the firing mechanism caused a critical jam. For a heart-stopping instant, demise seemed inevitable. Yet, the M1911's elegantly simple and remarkably robust design yielded to a sharp, decisive tap. The pistol cycled, the soldier fell. That civilian's seemingly eccentric innovation was poised to dictate the fates of men in the Pacific Theater. The humid air, thick with the scent of decay and gunpowder, rose from Bougainville's coral ridges like the exhalation of some ancient creature. Staff Sergeant Mike Kowalski, his back pressed against the pockmarked concrete of a former Japanese supply depot, methodically tallied his remaining ammunition. 7 rounds. That was the sum total of his arsenal. The sharp, urgent calls of Japanese soldiers, even through the smoke, needed no translation. They were advancing from multiple directions. His Thompson submachine gun lay inert beside him, its bolt locked open on an empty magazine. His M1 Garand, its receiver hopelessly compromised by shrapnel from an earlier mortar barrage, was beyond repair. Only the .45 remained. Through the acrid haze, 3 enemy combatants emerged from the jungle's edge, perhaps 60 yards distant. They advanced with the disciplined caution of seasoned troops, their formation suggesting a coordinated assault. These were not the raw recruits they had faced previously. These men were professionals. The lead soldier broke into a run at 40 yards, his Arisaka rifle held at the ready. Mike's mechanical mind, honed by years of diagnosing Ford V8 engines, registered the pistol's flawless operation. The barrel and slide remained locked together during the critical initial fraction of a second, absorbing peak pressure of 21,000 pounds per square inch with remarkable efficiency. As pressure subsided, a pivoting link tilted the barrel downward 7 degrees, disengaging it from the slide recesses. The spent casing ejected cleanly, and a fresh cartridge chambered with the unerring reliability of a machine tool. 2 more enemy soldiers advanced, their movements more hesitant following the swift demise of their comrade. Mike shifted position, utilizing the broken wall for cover. His thoughts, for a fleeting moment, drifted to his wife, Rose, likely finishing her shift at Willow Run. Riveting bomber panels with the same meticulous focus he now applied to the deadly calculus of survival. 6 rounds remained. 1,500 miles to the northwest, Lieutenant Tishi Yamamoto, instructing recruits outside Raba, emphasized the delicate nature of their Type 14 Nambu pistols magazine. The simplified catch mechanism, designed for mass production, was susceptible to moisture, leading to potential malfunctions. Yamamoto, having endured 18 months of Pacific combat, acknowledged the 8mm Nambu's modest 200 foot-pounds of energy, less than half that of the American .45. He harbored private doubts about arming eager young men with what he knew to be an inferior weapon. Military protocol, however, mandated unwavering optimism. The Type 14, weighing just under 32 ounces, was lighter and more convenient for extended jungle patrols. Yet, its weak cartridge and intricate magazine system were compromises born of wartime manufacturing pressures. The magazine spring operated at only 60% efficiency, and friction during feeding further hampered its performance. These were not flaws that could be rectified in the current production climate. Yamamoto, a former engineering student at Tokyo Imperial University, possessed a keen understanding of ballistics and metallurgy. However, recognizing superior design and possessing the means to replicate it were vastly different propositions. Japan's industrial capacity, strained across its vast Pacific dominion, could not match the precision manufacturing evident in American weaponry. 38 years earlier, in 1905, John Moses Browning stood in his workshop examining a half-finished mechanism that would redefine military sidearms. The concept of using the firearm's own recoil to operate a tilting barrel system, thereby unlocking the slide for reliable cycling, seemed impossibly complex to conventional thinking. Fellow designers dismissed it as too reliant on precise tolerances for dependable combat performance. But Browning, after decades immersed in the fundamental principles of firearms operation, had devised an elegant solution. His design employed a movable link, tilting the barrel downward to disengage from slide recesses, facilitated by a precisely angled ramp on the barrel interacting with a fixed stud in the frame. The underlying mathematics were a testament to controlled energy transfer, converting destructive recoil into constructive mechanical action. The genius lay not in complexity for its own sake, but in the purposeful integration of essential mechanisms. Every component served a critical function, the tilting barrel effectively addressing the challenge of maintaining a gas-tight seal during firing while enabling rapid unlocking for ejection and reloading, a balance that had eluded previous designs. Browning's approach was one of relentless iteration, machining and testing each component through hundreds of cycles, refining dimensions by thousandths of an inch. The barrel link, for instance, underwent 17 distinct modifications before achieving the precise angle and timing for flawless operation. This was not mere inspiration, it was systematic engineering. On Bougainville, Mike Kowalski was blissfully unaware of those meticulous workshop sessions or the theoretical principles governing his weapon. His sole concern was that when he pulled the trigger, the M1911 would perform exactly as John Browning had envisioned decades prior. The second enemy soldier advanced to within 20 yards, and Mike, with 5 rounds remaining, commenced the grim arithmetic that would determine his survival. On the crisp, clear morning of March 29, 1911, a palpable sense of anticipation filled the air at Springfield Armory in Massachusetts. Within the testing facility, military observers from 3 nations convened around a simple wooden table upon which 7 pistols lay arranged like instruments awaiting a critical procedure. Each represented years of development, national pride, and the collective expertise of the world's premier firearm manufacturers. Only one would be selected as America's next standard-issue sidearm. John Moses Browning, hands clasped behind his back, observed with quiet confidence as Army Ordnance officers prepared for what was to become the most rigorous firearms trial in military history. 6,000 rounds, 2 days, no cleaning, no maintenance, no adjustments. The pistol that endured would arm American soldiers for generations. Colonel William Crozier, Chief of Ordnance, addressed the assembled observers with the gravity befitting the occasion. "Gentlemen," he began, "we are gathered here to determine which automatic pistol will serve the United States Army. The test parameters are straightforward: continuous fire until mechanical failure or 6,000 rounds, whichever occurs first." Beneath the colonel's authoritative pronouncements, Browning detected a subtle undercurrent of skepticism. The Army had previously been disappointed by promising designs that ultimately proved inadequate under operational strain. The German Luger was the first to undergo the ordeal, its distinctive toggle action cycling smoothly through the initial magazines. The Prussian observers nodded approvingly as their national weapon processed round after round with meticulous precision. For 1,700 rounds, the Luger performed flawlessly, its 9mm parabellum cartridges feeding and ejecting with mechanical regularity. Then, at round 1,847, the toggle mechanism seized solid. German engineering, so precise in theory, had succumbed to the cumulative tolerances of sustained firing. A young German military attaché examined the failed weapon with evident disappointment. "Herr Colonel," he addressed Crozier, "the Luger is proven in service. This test exceeds reasonable combat requirements." His accent, precise and formal, carried the weight of Prussian military education, yet his plea fell on unreceptive ears. American combat doctrine demanded a level of reliability that far surpassed European standards. The Savage prototype, a testament to American ingenuity, featured a rotating barrel system intended to resolve the timing issues plaguing other designs. For 2,000 rounds, the Savage performed admirably, its unique operating mechanism drawing appreciative comments from the observers. Then, at round 2,156, the firing pin snapped with an audible crack that reverberated through the testing bay. Hastily manufactured metallurgy, rushed to meet testing deadlines, had failed under the relentless stress of continuous operation. Browning observed each failure with the detached interest of an engineer analyzing competing solutions to a shared problem. The Luger's complexity, with its numerous moving parts operating within critical tolerances, proved its undoing. The Savage's innovation, while clever, was insufficient to overcome fundamental material limitations. Both represented sophisticated thinking misapplied to the core design challenge. When the ordnance officers called for his submission, Browning stepped forward and placed his prototype on the testing bench with quiet assurance. The weapon appeared almost rudimentary compared to its European counterparts. No intricate toggle actions or elaborate rotating mechanisms, just a simple steel frame housing seemingly conventional components. The observers studied it with a degree of skepticism. One, noting the unusual barrel link system, inquired with palpable puzzlement. "Mr. Browning," Colonel Crozier asked, his voice laced with doubt, "perhaps you could explain this tilting barrel mechanism. It appears unnecessarily complicated for a military sidearm." The question reflected the Army's apprehension, having encountered numerous inventors who promised revolutionary improvements only to deliver elusive results under combat conditions. Browning moved to the pistol, beginning his explanation with the patience of a craftsman who had dedicated years to perfecting every detail. "Colonel," he stated, "the barrel and slide must remain locked together during the high-pressure phase of firing, approximately the first 16th of a second, when chamber pressure reaches 21,000 pounds per square inch. My system employs a pivoting link that tilts the barrel downward 7 degrees to unlock from the slide recesses once pressure drops. This allows the slide to complete its rearward travel for extraction and ejection." A visiting British observer leaned forward, intrigued. "But surely the timing must be critical. Any variation in ammunition or fouling could disrupt the sequence. His question echoed the prevailing wisdom that automatic pistols required pristine conditions for reliable function. "That is precisely why I designed it this way," Browning replied, his voice resonating with the quiet authority of absolute certainty. "The system is self-timing. The barrel cannot unlock until chamber pressure drops sufficiently, regardless of ammunition variations or environmental conditions. The physics dictate the sequence, not manufacturing tolerances." The test commenced at 1000 hours. Browning's pistol loaded with standard government-issue ammunition, 45 caliber automatic Colt pistol cartridges, each containing 230 grain bullets and 7 grains of smokeless powder. The initial shots echoed through the facility with the decisive report of a formidable cartridge, each recoil cycle driving the mechanism through its meticulously choreographed sequence. Hour after hour, the M1911 prototype continued firing, the barrel tilting and locking with metronomic precision. Each cycle concluded in approximately 1/10 of a second. Spent casings ejected cleanly to the right, and fresh cartridges fed from the magazine without hesitation. The observers watched with growing astonishment as the round count surpassed every previous failure point. At 3,000 rounds, when other pistols had long since succumbed to mechanical failure, Browning's design exhibited no signs of distress. The barrel link maintained its precise 7-degree arc, the slide reciprocated smoothly, and the firing pin struck each primer with consistent force. The accumulated heat from sustained firing had rendered the steel frame almost too hot to touch, yet the mechanism continued to function without adjustment. A French military observer consulted his pocket watch, performing a rapid calculation. "Mon Dieu," he murmured. "This weapon has been firing continuously for 4 hours. The barrel temperature must exceed 200 degrees Fahrenheit." His astonishment mirrored the prevailing belief that automatic weapons required cooling periods to prevent mechanical breakdown. By the close of the first day, Browning's pistol had fired 4,000 rounds without a single malfunction. The ordnance officers meticulously examined the weapon, searching for any indication of wear or damage that might foreshadow future failure. The barrel displayed minor throat erosion from the passage of hot gases, but the operating mechanism remained tight and precise. The tilting barrel system had unequivocally demonstrated its fundamental soundness under conditions that would have rendered conventional designs inoperable. The second day began with military punctuality at 800 hours. Fresh ammunition, meticulously cleaned firing benches, and careful documentation of every round fired characterized the start of proceedings. Browning remained in the observation area, his confidence unshaken by the mounting pressure. He possessed an intimate understanding of the mathematics governing his design, the precise relationship between chamber pressure, barrel timing, and mechanical stress that ensured reliable operation. At round 6,000, precisely 48 hours after testing commenced, Colonel Crozier declared a halt. Browning's pistol had successfully fired every cartridge presented to it, registering 0 malfunctions. This unprecedented reliability in an automatic weapon solidified its selection unanimously. On that cold March morning in Massachusetts, John Moses Browning's audacious concept had definitively proven itself the most dependable automatic pistol in the world. The cherry blossoms had long since fallen from the trees surrounding the Tokyo artillery arsenal when Chief Engineer Sato arrived for what he knew would be another protracted meeting with military procurement officials. April 15, 1942, marked 18 months since the attack on Pearl Harbor, and the immense industrial pressures of global conflict were transforming Japanese manufacturing in ways that deeply troubled his engineering sensibilities. The morning sun slanted through the windows of Conference Room 3, illuminating technical drawings and production charts that told a grim story of compromises dictated by necessity. Colonel Hayashi, with the brisk efficiency of a seasoned staff officer, spread the latest Type 14 production reports across the mahogany table. "Sato-san," he stated, his voice betraying impatience. "The Empire requires 400,000 pistols by year's end. Current production stands at 11,000 per month. These numbers are unacceptable." Sato studied the figures with the methodical focus that had established him as Japan's foremost small arms engineer. 11,000 Type 14s per month represented the absolute zenith of Japanese precision manufacturing capabilities. Yet, the military demanded the impossible. Across the vast Pacific, American factories were churning out M1911A1s at incomprehensible rates. Remington Rand alone was producing 45,000 pistols monthly, a figure exceeding the output of Japan's entire small arms industry combined. Colonel Sato responded carefully, choosing his words with the diplomacy required when delivering unwelcome technical realities to superiors accustomed to wielding authority through sheer will. The Type 14 necessitates 17 distinct machining operations on the frame alone, he explained. Each operation requires skilled craftsmen working within tolerances measured in hundreds of millimeters. We cannot simply add more personnel to accelerate production. The concept seemed foreign to Colonel Hayashi, whose experience with logistics involved orchestrating troop movements across continents, not the intricate manufacturing of precision components. "Then we simplify the design, remove unnecessary complexities," Hayashi countered. "The American pistol is crude by comparison. Surely we can emulate their production methods." Sato had examined captured M1911A1s with the fascination of an engineer studying a masterpiece of industrial design. Browning's tilting barrel system appeared simple only to those who failed to grasp its sophisticated engineering underpinnings. Every component served multiple functions, and the perceived crudeness concealed manufacturing techniques reliant on an industrial infrastructure that Japan could not replicate during wartime. The American design achieved simplicity through superior metallurgy and precision manufacturing, Sato elaborated, producing a cross-sectional diagram of the M1911's operating mechanism. Their tilting barrel system requires exact timing between chamber pressure and barrel unlock, but once manufactured to specification, it performs reliably under all conditions. Our Type 14 utilizes a simpler blowback action, yet demands precise magazine springs and feeding mechanisms for proper function. Lieutenant Tanaka, representing the Ministry of Munitions, leaned forward, his enthusiasm betraying a recent assignment to weapons procurement. "Sato-san, what specific modifications would increase production capacity while maintaining combat effectiveness?" His question reflected a dangerous assumption that engineering compromises could be made without significant consequence. Sato retrieved a dossier from his satchel, detailing the numerous technical alterations necessitated for Type 14 production over the preceding 6 months. Each change reflected a compromise, prioritizing expediency over genuine engineering artistry. The magazine safety had been discarded, a cost-saving measure that shaved 40 minutes off each firearm's assembly time, but introduced considerable safety risks. The magazine catch itself had been simplified, a modification that now made it prone to jamming when exposed to moisture or grit. A hush fell over the room as Sato continued his somber inventory of concessions. The firing pin spring's tension had been reduced to conserve strategic materials, leading to sporadic misfires. The magazine spring now operated at just 60% of its intended capacity due to inferior steel alloys, resulting in feeding issues during rapid firing sequences. Most significantly, quality control checks had been slashed from 12 to 4 stages, accepting a 5% failure rate that would have been unthinkable during peacetime manufacturing. Colonel Hayashi pored over the technical schematics, a palpable frustration etching itself onto his features. His military education had equipped him to triumph over enemy forces through superior strategy and unwavering resolve. However, manufacturing constraints presented an entirely different species of challenge. "These alterations," he inquired, his voice taut, "do they substantially diminish combat efficacy?" The question compelled Sato to confront the ethical ramifications of his engineering choices. Every concession made in manufacturing standards would inevitably translate into Japanese soldiers engaging in combat with unreliable weaponry. He had spent countless sleepless nights calculating the human toll of each technical shortcut, acutely aware that his recommendations would dictate whether young men lived or perished in the brutal jungle warfare across the Pacific. "Colonel," Sato began, his gaze fixed on the schematics. "The cumulative impact of these modifications reduces the Type 14's dependability by roughly 30% when compared to its original specifications. In sustained combat, soldiers will encounter magazine feeding malfunctions, intermittent misfires, and difficulties with field maintenance. The 8mm Nambu cartridge already delivers less than half the stopping power of the American .45 caliber round. These compounding reliability issues further exacerbate our tactical disadvantage." Lieutenant Tanaka attempted to bridge the divide between the realities of manufacturing and the demands of military necessity. "Perhaps we could prioritize certain modifications over others, retaining critical components while accepting compromises in less essential areas." Sato appreciated the young officer's attempt at logical reasoning, but wartime production operated under a distinct set of principles compared to peacetime engineering optimization. The fundamental constraint was not design complexity, but rather industrial capacity. American factories utilized precision machinery that maintained tolerances automatically. Japanese craftsmen achieved similar precision through individual skill, but such methods were incapable of scaling to meet current production demands. The contrast with American manufacturing prowess was stark and disheartening. While Japanese engineers grappled with maintaining quality while simultaneously increasing output, American factories were achieving both through industrial methods that Japan could not replicate. The Willow Run plant near Detroit was churning out B-24 bombers at a rate of 1 aircraft per hour, a manufacturing feat that represented an industrial capability beyond Japanese comprehension. Colonel Hayashi gathered the technical reports with the decisive motion of someone accustomed to making difficult decisions under duress. "Sato-san, implement all proposed modifications immediately. Commence production planning for 600,000 units by March of 1943. The Empire's survival hinges upon equipping our forces, even with imperfect arms." As the meeting concluded and officials dispersed from Conference Room 3, Sato remained seated, his attention absorbed by the technical drawings that represented 30 years of his engineering career. Each modification noted on those papers would compromise the reliability of the weapons carried by Japanese soldiers facing American forces armed with John Browning's masterpiece of design and manufacturing. The mathematics of industrial warfare were unforgiving. Superior engineering multiplied by superior manufacturing capacity yielded a tactical advantage that courage alone could not surmount. That evening, Sato stood within the arsenal's production facility, observing workers implement the latest series of manufacturing shortcuts. The skilled artisans who had dedicated decades to perfecting their metalworking techniques now rushed to meet impossible quotas, accepting tolerances that defied every principle of precision engineering. The Type 14 pistols emerging from these assembly lines would function adequately under ideal conditions, but combat rarely afforded such circumstances. In workshops across the Pacific, American laborers were applying the very same precision manufacturing principles that had enabled Browning's design, producing firearms of unparalleled dependability in unprecedented numbers. Rain lashed the coral ridges of Guadalcanal with tropical ferocity as the November darkness descended upon Henderson Field like a black shroud, intermittently pierced by distant muzzle flashes. Staff Sergeant Mike Kowalski led his 8-man patrol through knee-high kunai grass towards Grid Square 27 Alpha, where intelligence indicated a Japanese observation post directing artillery fire onto Marine positions. The mission was straightforward in concept, but deadly in execution. Neutralize the spotters before dawn ushered in another day of accurate enemy bombardment. Mike's M1911A1 rested heavily in its leather holster, loaded with 7 rounds of hardball ammunition that had traveled 8,000 miles from Lake City Arsenal in Missouri. The pistol's 39 ounces felt reassuring against his hip as he navigated the chaotic terrain of bomb craters and fallen palm trees that characterized Guadalcanal's contested landscape. Behind him, Corporal Johnny Martinez carried the squad's Browning automatic rifle, while 6 other Marines fanned out in standard patrol formation, each man responsible for a 30-degree sector of observation. The intelligence report had been precise: 12 Japanese soldiers operating a concealed observation post approximately 800 meters inland from the Tenaru River. What the intelligence had failed to mention was Lieutenant Teishi Yamamoto's presence with this particular unit, or his tactical expertise forged through 2 years of Pacific combat. Yamamoto had positioned his observation post not on the obvious high ground, but within a depression encircled by dense vegetation, rendering it invisible to aerial reconnaissance while offering perfect fields of fire in all directions. At 2300 hours, Mike's patrol moved through a grove of coconut palms, shattered by prior bombardments, their splintered trunks creating a labyrinth of natural obstacles. The distant rumble of artillery echoed across the island like approaching thunder, punctuated by the sporadic crack of sniper fire from Japanese positions still holding out in the island's interior. Mike checked his watch. They had 4 hours until dawn to complete their objective and return to friendly lines. Yamamoto crouched in his meticulously prepared position, studying the terrain through captured American binoculars, his Type 14 Nambu pistol resting within easy reach. The weapon's magazine contained 8 rounds of 8mm ammunition. Each cartridge produced barely 200 foot-pounds of muzzle energy, less than the .45 caliber rounds carried by enemy patrol leaders. However, Yamamoto's engineering background had instilled in him the ability to compensate for equipment limitations through tactical superiority. His observation post occupied a natural depression, 30 meters in diameter, enveloped by dense jungle growth that concealed firing positions for his entire squad. 2 Type 96 light machine guns covered the most probable avenues of approach, while riflemen, positioned at carefully surveyed distances, established interlocking fields of fire. The position exemplified Japanese small unit tactics at their finest, leveraging terrain and concealment to offset American advantages in firepower and equipment. The initial contact occurred at 23:47 hours when the Marine point man, Private Eddie Santos, triggered a concealed tripwire connected to empty ration cans filled with pebbles. The metallic clatter reverberated through the jungle for perhaps 2 seconds before Yamamoto's machine guns erupted from concealed positions 60 meters away. Tracer rounds sliced through the darkness like deadly fireflies, forcing the Marine patrol to dive for whatever cover they could find amidst the shattered palm trees. Mike rolled behind a fallen log as bullets chewed bark inches from his head. His tactical mind automatically processed the geometry of the ambush. The machine gun positions were expertly sighted to create a killing zone devoid of dead space. While the muzzle flashes revealed at least 6 distinct firing positions arranged in a defensive arc, this was not a chance encounter. The Japanese had been anticipating their arrival. Corporal Martinez brought his BR into action from a position 20 meters to Mike's left, unleashing 20-round bursts towards the enemy muzzle flashes in an attempt to suppress their fire. The Browning automatic rifle's .30-06 cartridges possessed sufficient power to penetrate light cover, but the Japanese had chosen their positions wisely. Most of Martinez's fire impacted harmlessly against thick tree trunks and coral outcroppings. Yamamoto observed the developing firefight with professional interest, noting the American patrol leader's rapid assessment of the tactical situation and his swift coordination of defensive fire. These were not the green troops Japan had faced in the war's early months. These Marines exhibited the aggressive competence characteristic of veteran units, but tactical skill could not overcome the fundamental disadvantage of fighting from an exposed position against a prepared defense. The Japanese machine guns maintained disciplined fire, conserving ammunition while pinning the Marines in increasingly untenable positions. Yamamoto's riflemen waited patiently for clear targets. Their Arisaka rifles were loaded with steel core ammunition capable of penetrating the limited cover available to the American patrol. The tactical situation heavily favored the defenders, yet Yamamoto understood that American artillery and air support would eventually tip the scales if the engagement persisted past dawn. Mike recognized that conventional small unit tactics would be insufficient to dislodge the enemy position before Japanese reinforcements arrived, or daylight exposed his patrol to accurate long-range fire. He made the decision that would define the engagement: a desperate flanking assault utilizing his pistol as his primary weapon, while his squad provided covering fire. The 7 rounds of his M1911A1 would have to see him through close-quarters combat at ranges where rifle fire became impractical. At precisely midnight, Mike initiated his flanking maneuver through dense undergrowth that concealed his approach from Japanese observation. Each step required careful placement to avoid dry branches or loose coral that might betray his presence. The sounds of the ongoing firefight masked most of the noise, but Yamamoto's tactical experience had taught him to position security elements along likely approach routes. The first Japanese soldier materialized at 15 feet, emerging from concealment with his Arisaka rifle held at port arms. Mike's M1911 came up smoothly and swiftly, muscle memory from countless hours of training overriding conscious thought. The .45 caliber bullet struck center mass with devastating effect. The 230-grain slug transferred 400 foot-pounds of energy in a single massive impact that dropped the enemy soldier instantly. Yamamoto heard the distinctive bark of the American .45 and immediately grasped the tactical shift occurring within his defensive perimeter. An enemy patrol leader armed with a pistol signaled a close-quarters assault, likely coordinated with supporting fire from the pinned patrol members. He drew his Type 14 Nambu and moved toward the sound of Mike's shot, aware that the next few minutes would determine whether his observation post survived until reinforcements arrived. The two men advanced toward each other through jungle growth so dense that visibility extended barely 10 feet in any direction. Both carried sidearms loaded with ammunition that represented their respective nations' industrial philosophies. The American emphasis on stopping power and reliability versus Japanese priorities of weight reduction and manufacturing efficiency. Neither man knew the other's identity or background, but both understood that their survival hinged upon their weapons functioning flawlessly as combat ranges narrowed to pistol distance. At an 8-foot separation, they spotted each other simultaneously through a gap in the vegetation. Two professional soldiers whose training and equipment would dictate the outcome of this deadly encounter in the Pacific darkness. The first pale light of November 28, 1943, crept across Guadalcanal's ravaged landscape like a reluctant witness to the carnage strewn across Grid Square 27 Alpha. His back pressed against a bullet-scarred coconut palm, feeling warm blood seep through the field dressing on his left shoulder as he tallied the night's engagement losses. 3 Marines lay dead, 2 grievously wounded requiring immediate evacuation, and his own patrol strength reduced to 5 effective combatants facing an unknown number of Japanese defenders entrenched in prepared positions. 30 meters distant, Lieutenant Teishi Yamamoto crouched behind the twisted wreckage of what had once been a Japanese radio antenna. His Type 14 Nambu felt heavy in hands that trembled slightly from exhaustion and blood loss. The 8mm pistol contained but a single cartridge. The magazine catch mechanism had failed during the night's fighting, precisely as Chief Engineer Sato had predicted in those austere meetings at the Tokyo arsenal. Moisture from Guadalcanal's oppressive humidity had infiltrated the simplified mechanism, causing the catch to bind and precluding magazine changes under combat conditions. Mike's M1911A1 held 6 rounds of .45 caliber ammunition, the dependable pistol having functioned flawlessly through 12 hours of jungle warfare that had tested every facet of Browning's design philosophy. Sand, mud, and coral dust had accumulated in every crevice of the firearm, yet its simple, robust mechanism continued to cycle with mechanical precision. Each time he had squeezed the trigger, the tilting barrel system had locked and unlocked exactly as intended, ejecting spent casings and feeding fresh cartridges without hesitation. The tactical situation had devolved into a deadly impasse that neither professional soldier could resolve through conventional means. Yamamoto's remaining troops, he estimated at 4 effective fighters from his original squad of 12, controlled the high ground and possessed superior fields of fire. However, American artillery was registering targets on their position, and dawn would bring close air support poised to neutralize any Japanese advantage. Both men understood that decisive action was imperative within the next 30 minutes. Yamamoto examined his damaged pistol with the detached analytical focus of an engineer scrutinizing a flawed mechanism. The Type 14 embodied everything that was fundamentally wrong with Japan's wartime manufacturing doctrine. Corners cut in the name of production efficiency, quality sacrificed for quantity, and field reliability compromised by procurement decisions made thousands of miles from the combat zones. He had carried this particular weapon for 18 months, maintaining it meticulously despite its inherent design deficiencies, knowing his life might depend on its function at a critical juncture. The irony was not lost on him that his engineering education at Tokyo Imperial University had included in-depth study of American manufacturing methodologies, including the analysis of captured firearms that showcased superior metallurgy and precision machining. He had studied technical papers detailing Browning's patents, comprehending the mathematical principles that rendered the tilting barrel system so remarkably reliable. Knowledge without access to superior industrial infrastructure remained merely an academic exercise. Mike's tactical assessment was equally grim, albeit for different reasons. His squad had accomplished its primary objective. The Japanese observation post was neutralized and could no longer direct artillery fire onto Henderson Field. However, extraction remained problematic, with wounded Marines requiring immediate medical attention and likely Japanese reinforcements approaching from inland positions. The M1911 in his hand represented his final safeguard. 7 rounds that might determine whether any of his men would ever see home again. Through the morning haze, both men could discern the distinct whine of approaching aircraft engines. American F-4U Corsairs vectoring toward their position to provide close air support for the Marine patrol. The sound signified salvation for Mike's battered squad, but certain annihilation for any Japanese troops remaining in the area when the fighters arrived. Time was rapidly diminishing for both sides to resolve their tactical predicament. Yamamoto made his decision with the calm deliberation of one who had accepted the mathematical realities of his situation. Rather than await American air power to obliterate his position, he would attempt one final assault to breach the Marine perimeter before his ammunition was depleted. His single remaining cartridge would have to encompass everything. Yet, he had studied ballistics long enough to understand that placement held greater significance than projectile energy when engagement ranges contracted to pistol distance. But as he prepared to advance, something within the young Japanese officer's tactical mindset rebelled against the futility of the gesture. His engineering training had taught him to recognize when problems lacked viable solutions, when continued effort would merely escalate casualties without altering outcomes. The Marines were wounded but organized, bolstered by superior firepower and incoming reinforcements, while his own position was untenable regardless of individual courage or tactical acumen. Mike perceived the moment when his opponent's firing slackened, then ceased altogether. Through gaps in the jungle foliage, he observed Japanese soldiers initiating a disciplined withdrawal toward inland positions, moving with the practiced efficiency of troops who understood when tactical situations had become hopeless. The decision reflected military professionalism rather than outright defeat, an acknowledgement that preserving trained soldiers for future engagements better served the emperor's interests than futile, sacrificial assaults. Lieutenant Yamamoto led his surviving troops in a fighting withdrawal that showcased the tactical proficiency Japanese forces had developed through 2 years of Pacific combat. They advanced in bounds, with one team providing covering fire while another displaced to successive positions, maintaining unit cohesion despite overwhelming American advantages in firepower and air support. His damaged Type 14 remained holstered. The single cartridge was too precious to expend on long-range shots with minimal probability of success. As the sounds of Japanese movement faded into Guadalcanal's jungle interior, Mike allowed himself a moment of professional respect for an adversary who had fought with skill and intelligence despite inferior equipment. The engagement had revealed something beyond mere tactical competence. It had illuminated the human dimension of technological warfare, where individual soldiers compensated for equipment limitations through expertise and sheer determination. Corporal Martinez approached through the scattered debris of the night's battle, his bar slung across his shoulders as he surveyed the tactical situation with experienced eyes. "Sir, the Corsairs are maneuvering for another approach, but it appears Charlie has retreated to the elevated terrain. We've sustained 3 fatalities, 2 personnel with minor injuries who can still move, and Johnny will require medical attention urgently." Mike acknowledged the report, his focus already pivoting to the pressing needs of getting the injured to safety and withdrawing the patrol. The M1911 was returned to its sheath, having functioned precisely as John Browning had envisioned when he engineered the locking wedge system in his workshop in Utah, approximately 40 years prior. 7 rounds discharged, resulting in 7 enemy combatants neutralized without a single operational hitch, even in circumstances that would have strained any automatic firearm. 6,000 miles distant in Detroit, Rose Kowalski was concluding yet another graveyard shift at Willow Run, fastening aluminum plates that would form B-24 Liberators earmarked for engagements in the Pacific Theater. She remained unaware of her spouse's fortunate escape from harm or the contribution of advanced American ingenuity to the success of small troop engagements throughout the Solomon Islands. Nevertheless, her labor, amplified by countless comparable endeavors across America's manufacturing hubs, was supplying the essential technological infrastructure that ensured the survival of combatants like Mike in the treacherous jungle warfare that pushed equipment durability to its limits.